All right, and in this video we're going to discuss the formal definition of limit, or actually remember it and apply it to three dimensions. So this might take you back to your Calc 2 fall semester, and I might encourage you to review your notes on that if you need to, mainly because a lot of everything that we're going to discuss here is related to that, just in many dimensions now. That's all. So when we discussed the formal definition of a limit previously, we kind of had this idea that, okay, well, we talk about the limit as x approaches a of f of x is equal to L, and well, adapting it to three dimensions, we just add vector notation on everything. And we said that that is the same as, so this is if and only if, and this is this is using a little bit more colloquial language. We can make f of x, f of vector x, be as close to L as we want by forcing vector x to be as close to A. Okay, and so the idea here is that if we want the distance between vector x and vector A to be small, okay, if we have that condition, then that's going to force the distance between f of vector x and this L to be small as well. Okay, another way to say that, using more formal notation, etc., is that we have the limit as vector x approaches vector A of f of vector x equaling L if and only if, for all epsilon greater than 0, yes, epsilon, we love epsilon, there exists a delta greater than 0, such that when, I should actually say, if we have the distance between vector x and vector A to be less than delta but still positive, that forces or gives us that f of vector x minus L, let's try that again, minus L is less than epsilon. That's our definition of a limit. Okay? Again, just adapted to three dimensions. Okay? Well, that's fun. Let's actually use it in an example. All right. So we're given this limit, right? We can do direct substitution to get this. Okay, we haven't talked about continuous, but yes, this function is continuous, or this multivariable function is continuous at this point, which allows us to use direct substitution, blah, blah, blah. Okay, great. And here what I'm going to do is I'm only going to do the proof step. Remember last year we broke it into a think step and a proof step, or a step 1, step 2. I don't remember the language we use. In any case, though, the think portion, which establishes the delta that we choose, is actually described on page 100 of the textbook, onto page 101. So I would actually recommend that you maybe pause the video and look through that think step and and figure out why we chose, or why we're choosing this value of delta that we do in the proof. Okay, but if I do the proof, okay, what I'm going to say is, given any epsilon greater than 0, or whatever language, or fix, whatever thing is equivalent, we choose epsilon to be, choose delta rather, to be epsilon over 10. Okay, and again, that's to figure out where I got this value, review the think step. Okay, and then we just kind of start with our proof. Okay, then when we have the distance between x, y, z and this point of 1, -1, 2, when that distance is less than delta, that forces, or implies, gives that the distance between 3x minus 5y plus 2z minus 12. Okay, what I can write that as is, okay, and now I just kind of have to break that 12 apart a little bit. What I'm going to do is I'm going to break it into a 3, and a 5, and or 3, a 5, and a 4. Let's see if I did that right. Yep. Everything adds to 12, so we're good. Okay, and what I'm going to do is say that, well, that 3, I'm going to, and those are all negatives, right? Okay, this is going to equal 3, and then x minus 1. Okay, but really that minus 1 is a minus 3. Okay, and then minus 5, and then that's where the 5 is going to go, y plus 1. Okay, again, just moving that around, and then plus 2, and then z minus 1, that's where, oh, z minus 2, rather. Okay, so I just broke that apart to get this. Okay, and the reason I did that is, well, that's, the point is going to pop out, right? That's where I'm approaching. Now, the next step is where I get to use the triangle inequality. Okay, so if you have to look that up, please do. What you end up getting is 3x minus 1, absolute value, plus, and then an absolute value of 5y plus 1, plus absolute value 2, z minus 2. Okay, and I can actually say, well, pull the constants out, 3, x minus 1 in absolute values, and then plus 5, y plus 1, plus 2, z minus 2. Okay. And now, if I'm within this neighborhood, right, then each of these components is going to be less than delta. Okay, so what I end up getting is 3 is less than delta, plus 5 delta, plus 2 delta. And that's a consequence of this part here. Okay, I'm within a delta neighborhood of each of these. Okay, so this is just 10 delta, right? Right, and but then I'm saying, well, this delta is actually epsilon over 10 by what I chose from above, right? Which is just epsilon. And that would complete my proof. Okay? The trickiest step of this whole thing is actually working the choice of delta out. Okay? So be ready to do that. Otherwise, a lot of this is just remembering kind of algebra, getting the algebra to work out the way you want it to, and remembering the triangle inequality. Okay, that's going to pop up in almost all of these proofs. Okay. Other than that, that completes this video. Stay tuned for one final video on continuity.